In this section, we're going to talk about percent composition and determining empirical formulas. Percent composition we've seen earlier in the year, but we're going to revisit it in terms of empirical formulas. So for example, what is the percent by mass of oxygen in a water molecule? Well, the mass of oxygen is 16 grams per mole. The mass of water is 2 times 1 plus 1 times 16, or 18 grams per mole. If we take the weight of the oxygen and we divide by the total weight of the molecule, multiply by 100 since it is a percent, we find out that water is 88.9% oxygen by mass. Here's another problem. What is the percent by mass of oxygen in nitric acid? Notice we have 3 oxygens in nitric acid, each weighing 16 grams per mole. So if we had 1 mole of nitric acid, we'd have 48 grams of oxygen. If we add up all of the elements, the hydrogen, the nitrogen, and the 3 oxygens, the total weight of the molecule would be 63 grams. So 48 divided by 63 times 100 gives us 76.2% oxygen by mass in nitric acid. So let's talk about empirical formulas. An empirical formula is nothing more than the lowest ratio of moles of each element in a compound. For example, water, H2O, is essentially telling us that there's 2 moles of hydrogen for every 1 mole of oxygen. If you keep that in mind, empirical formulas are actually quite easy. So what we're going to do is we're going to determine an empirical formula here for a compound that contains 7.89% carbon and 92.1% chlorine. Our job is to figure out what its empirical formula is. So the first thing we're going to do is we're going to pretend this is out of a 100-gram sample. And we're going to go ahead and change those percent signs to grams. So 7.89% would represent the same thing as 7.89 grams if we were talking about a 100-gram sample. So our first step to get this empirical formula is to take the grams of each element in the compound and divide it by its molar mass. So the molar mass of carbon is 12 and the molar mass of chlorine is 35. If we divide each of their masses by their molar masses, we can get their moles. Notice this is our ratio of moles of carbon to moles of chlorine, but we want the lowest whole number ratio. So I'm going to take both of these moles and divide it by the smallest number of moles, which is 0.658. If I divide both of them by 0.658, I get 1 mole of carbon and I get 4 moles of chlorine. So the ratio is 1 mole to 4. If we were to write this out as an empirical formula, we would write it out as CCl4, meaning 1 mole of carbon for every 4 moles of chlorine. We're going to go through another example here where things don't work out perfectly fine like they did in the last one. Propane is a hydrocarbon, meaning it only contains hydrogen and carbon. It is 81.82% carbon and 18.18% hydrogen. Let's figure out its empirical formula. Still the same steps as before. We're just going to add one more thing into this equation. The first thing we do is we change their percentages into grams, and we write those down. 81.82 grams of carbon, 18.18 grams of hydrogen. We divide each of them by their molar masses and get our moles. We look and see which one is the smallest number of moles, which in this case is carbon, and we divide by that number. That'll give us a relative number of moles. It's 1 mole of carbon for every 2.67 moles of hydrogen. Well, 2.67 you cannot round up to 3. In order to round that number of moles of hydrogen up to 3, we would have to have a number greater than 2.9, and if we were going to round that down to a 2, we would have to have a number less than 2.1. Since this is neither of the cases, we need to find something to multiply this number by in order to get it to be a number that can be rounded up or down. I'm going to try 3. And notice if I multiply the moles of hydrogen by 3, I also have to multiply the moles of carbon by 3. And when I do that, I get 3 moles of carbon and 8.01 moles of hydrogen. Notice the 0.01 allows us to round the moles of hydrogen down to 8. So we have 3 moles of carbon for every 8 moles of hydrogen, and written as an empirical formula would be C3H8.